Hi, my name is Stein, and I'm a technical product manager at VMware's Network and Security business unit. And in today's whiteboard, I'll talk about the NSX Distributed IDS and IPS, or Distributed Intrusion Prevention and Detection System. Now, the goal of an IDS and IPS is to be able to detect and prevent exploit attempts against your applications. And in today's world, there's two ways that IDS and IPS appliances can do that. There's what we call host-based intrusion prevention and detection systems. And these really are a piece of software that runs inside every of the guest VMs. Now, these systems have access to a lot of context because they're run inside the operating system, but they also come with some challenges. They're hard to operationalize, and also because they're not actually isolated from the workload themselves, that means they're often vulnerable to what the protected asset itself is vulnerable for as well. The second type of IDS-IPS solution is called the network-based IPS, which is what you can see here. And a network-based IDS is typically a physical appliance that gets deployed in a network, commonly sits behind a physical firewall, and it relies on hairpinning. It relies on traffic to be steered to that physical appliance so it can provide the IDS and IPS services to that traffic. Hairpinning comes with a challenge. Of course, it means that a lot of traffic is being sent across a network. That creates choke points. And that means that customers are often limiting the amount of traffic that they actually send to their IDS appliance, which means that they have to be selective in where they apply the protection that these systems can offer. Another challenge with physical IDS IPS appliances is that they don't really scale well. And what this means is as your organization is growing, you're adding in additional hypervisors, you're adding in additional workloads. That means you have to keep scaling up your additional physical IPS IDS clusters. You have to keep deploying physical IPS appliances. Another challenge as well is that these are really inadequate. If you look at my drawing here, you can see that I have two VMs here. They are connected to a single segment. This is a single, say, call it the purple VLAN. There really isn't any feasible way to apply intrusion prevention and detection to workloads that are deployed in the same logical segment here, which is another key challenge. Another problem is lack of mobility. As you know, in the modern day data center, workloads are very mobile. With DRS and vMotion, a workload can move from one hypervisor to another hypervisor, from one cluster to another cluster, or even from a data center to another data center. And that means that the flows that were going through the original IPS may end up on a different IPS appliance who doesn't have any context about that particular flow and may not even have the same policy applied. Now, the biggest challenge, however, is lack of context. If you look at these physical IPS appliances, they see a lot of network traffic, but they don't really have any context. They see a source and a destination IP address, but they don't know if the target of a particular exploit is actually a vulnerable database server that has critical sensitive data deployed in production, or it's a print server that's not even vulnerable to a specific exploit. So this lack of context makes it very difficult for a security team to determine if an event is a true or a false positive, what is the priority that should be assigned to an event, and what is the appropriate action that should be taken. It also means that on these physical IPS appliances, you're basically going to enable all of your signatures and match all of that signatures against all of your traffic. It doesn't matter if that traffic is targeting a Apache server here or it's targeting a database server. The same signatures will be applied to all the traffic, which means that these systems have very significant impact on throughput. The NSX Distributed IDS IPS combines some of the best qualities of a host-based IDS with a network-based IPS. Similar to the architecture of the distributed firewall, our distributed IDS IPS is deployed right inside the hypervisor itself. It doesn't require any additional components. So as long as you do your NSXT host prep, all of the NSXT components are installed, including distributed switch, the distributed firewall, and the distributed IDS IPS. You don't need to deploy additional workloads. You don't need to deploy additional physical appliances, or you don't need to deploy anything on the guest VM. So, because of this distributed architecture, this also means that we don't have to hairpin traffic to any physical appliance. The IDS IPS is applied to any VNIC of any workload, regardless if this workload here is talking to another workload that is connected on the same switch or a different switch. We always apply intrusion detection and prevention thanks to our distributed architecture. With the NSXT Distributed IDS and IPS, we also provide curated signatures. And for those of you who are familiar with the distributed firewall, you might be familiar with a concept called applied to. And applied to is basically what allows us to only apply the relevant firewall rules to specific workloads. Imagine if you have a database server here, it really doesn't make any sense to apply a firewall rule that allows traffic from the web application to the application tier here to apply that to our database server as well. It's not relevant to that. The database server is never going to see that traffic. Same thing applies to an IPS. Imagine you have an IPS signature that detects an exploit that is very specific to Linux. It would not make any sense to apply that signature to a workload that is running Windows. So with the distributed IDS and IPS, we can be very selective in where we apply the IDS, IPS signatures. We can choose to only apply the signatures where they make sense. And in order to do that, you need context. And this is another benefit of being embedded in the hypervisor. That means that we have access to a lot of context. We know exactly the name of this virtual machine. We know what application that a virtual machine is part of. And thanks to VMware tools and the guest introspection framework, we even know what is the operating system that is running, what is a user that is logged into a workload, and even what are the processes that are running on that workload. And to an IPS operator, context is really important. If you don't have any context, it becomes really hard to determine if an event is a true or a false positive and what should be the priority it gets applied to an event. But if you know that this is Apache and the exploit is an Apache exploit, and this is deployed in production, you can then assign the appropriate priority to that. So context is really, really important. And then another key benefit here is policy and state mobility. With the distributed firewall, as well as with the distributed IDS, not just the firewall policy, but also the IPS policy moves along right with the virtual machine from one hypervisor to the next hypervisor, so you don't have to reapply that same policy. In addition to that, the firewall state, the connection state, moves along with that virtual machine as well. Many of our customers need to meet regulatory compliance. Think, for example, about PCI DSS or HIPAA. And in order to meet compliance, often things like security controls like IDS, IPS are required. Now, with the distributed IDS and IPS, we can be very selective. We can choose where we enable or where compliance is required. We can apply a security tag to those workloads and then apply an intrusion prevention policy to all the workloads that have security tag. Now, virtual zones, virtually all of our customers have a requirement to segment workloads that belong to a different zone. Think, for example, different lines of business or workloads that are deployed in production versus workloads that are deployed in a development environment. In many cases, these need to be isolated from each other. And customers need to apply a separate firewall policy to these different zones and even a separate IPS policy. Now, in the traditional world, this is achieved often by air-gapping these environments, meaning that these workloads are deployed on separately physical infrastructure. Especially in DMZ environment, often the DMZ workloads are deployed on separate hardware, even sometimes with their own firewalls versus the internal network. Using the NSX Distributed Firewall and distributed IDS and IPS, we can achieve much better consolidation. You can run workloads that belong in production and workloads that are deployed in a development environment or workloads that belong to different tenants or DMZ and non-DMZ on the same physical infrastructure. And then you can use the distributed firewall and the distributed IDS IPS in order to achieve that same isolation that you would have with physical air gapping. Of course, you can also apply a different or separate IDS IPS policy to each of these zones. So we can have a separate IPS policy to our production zone and a separate policy here applied to our development zone. Now, as customers are moving, virtualizing their data center infrastructure, they're virtualizing and moving into the SDDC, this is also an opportunity for customers to replace these physical firewall and IDS appliances they have with the NSX Distributed Firewall and Distributed IPS. The benefit of doing this both for the Distributed Firewall and Distributed IDS is that you can have a single security policy for both that stretches the whole SDDC. Then a final use case of the NSX Distributed IDS IPS is the detection of lateral movements. Almost invariably, the initial way that an attacker gets into the environment is not the actual objective of an attack. The actual objective of an attack is much more likely going to be a database server that runs on the inside of the environment, and the attacker wants to be able to get that valuable data or wants to compromise that data in order to do the maximum amount of damage. So that means that an intrusion detection and prevention system has to be able to not just detect this initial point of attack, but also has to be able to detect how an attack is laterally spreading in the environment from workload to workload. And because the distributed IDS is deployed in front of every single workload, we're able to detect every stage of this lateral spread. And of course, without distributed firewall, we already greatly reduced the attack surface by having a microsegmentation whitelisting policy that only allows traffic here from this workload to that workload on a specified port. With layer 7 application identity, we can reduce that attack surface even more. With the distributed IDS capability, now we can completely close that attack surface, regardless if an attack is moving initially into the environment or it's laterally moving from a workload to the workload in your data center. And with that, if you want to learn more about the NSX Distributed IDS IPS, check out the VMware NSX YouTube channel for demos and additional information, and also check out the VMware NSX Tech Zone. Thanks for watching.